Okay, so we're going to continue with angles here. Another way to measure angles in addition to degrees is going to be to look at some subdivisions of degrees. Okay, just like with length, if we were to take 1 foot and chop up into 12 pieces, we get each of those called an inch. Okay, so we're looking at subdivisions of a bigger unit. In a similar way, we're going to look at a degree and then we're going to chop it down. So we already said that if you took a circle and you cut it into 360 little pieces, each of those is called 1 degree. Okay, but now let's zoom in on that 1 degree and get an even more fine unit. Okay, so if I were to zoom in on that guy, so this is 1 degree. If I were to then chop it up into 60 little teeny pieces, so you chop it up into 60 pieces and all of them, they all come out from the center. We get 60 little teeny wedges, and each of those is considered 1 minute of a circle. So you get degrees and minutes. Okay, so each of those is considered 1. I better make that bigger. 1 minute, or shorthand we use an apostrophe. Okay, so 1 minute is 1/60th of a degree, or you could say that 60 minutes equals 1 degree. Okay, so that's the relationship between them. Now, if you were to take 1 minute and zoom in on that, just like we did with the degrees, so now we've got an angle here of 1 minute, and then you chop that up into 60 more pieces, so now we're getting very tiny pieces of an angle. Okay, or very tiny angles, pieces of a circle, I should say. So each of those, you do 60 of them again, and you get what we call seconds. Okay, so degrees, minutes, and then finally seconds. So each of those would be 1 second, and in shorthand, we use 2 apostrophes. Okay. Okay. So we call this the degree, minute, second units. Okay. Or we abbreviate it often as DMS. Okay, degree, minute, seconds. Okay, so like I said, there are 60 seconds in 1 minute. So 60 seconds equals 1 minute. And if there's 60 seconds in 1 minute and 60 minutes in 1 degree, then that means there would be 3,600 seconds in 1 degree, right? If you multiply 60 times 60. So there are 3,600 seconds in 1 degree. Okay. All right, so now we want to be able to take an angle that's measured in degree, minutes, seconds, and think about what it could be in terms of just degrees if we use decimals, or vice versa. Okay, convert from one to the other. If you had half of a degree, that's equivalent to 30 minutes. Okay, so half of 1 degree is 30 minutes. Okay, so an example, let's say we wanted to convert 42 degrees, 15 minutes, and 10 seconds. That's our degree, minutes, seconds. And I want to convert that to decimal degrees. Okay, so what we know of, well, the 42 is already in degrees, so I don't have to do any conversion. What we're really trying to do is convert the minutes and the seconds into degrees. To do that, we're going to take 15 minutes, and really 15 minutes is 15/60ths of a degree. So we're going to take, oops, not the 42. We're going to take the 15, divide it by 60, because that's the fraction of a degree, and that's going to equal a quarter, or 0.25 degrees, right? A quarter of a degree. 15/60 is a quarter. Likewise, we're going to look at the 10 seconds, sorry, and we're going to think of that as 1/3600th of a degree. Okay, so 10/3600. That's how many degrees 10 seconds is. Now that one's a little bit harder to come up with just off the top of my head. However, I do have my handy calculator. I will be using this TI-84 Plus for this course, so you'll see me flash this from time to time. The calculator, I did this calculation earlier, gives me 0.0027 repeated as an output. Okay. Now really the calculator shows 77778 because it doesn't necessarily repeat, it just rounds the last decimal off. But I know that it's going to be a repeating decimal because the denominator is a multiple of 3. Okay. So it's going to work out that way. Actually, a multiple of 9 in this case. Okay, so now I want to put all these together. So if I had an angle that opened up at 42 degrees, 15 minutes, and 10 seconds, then the combination is the sum of those 3 parts. So we'd have 42 degrees plus the 0.25 degrees plus the 0.0027 repeated degrees. Okay, so I've basically converted each of them into a degree, and because we're adding them together, we just put them all together and we'll end up with 42.2527 repeated degrees. Okay, so that's our decimal degrees. Now you may be asked in the homework or on a test to round this off somewhere, okay, rather than showing a repeated decimal. And so you just need to be aware of that in the instructions. Make a note and make sure that you do round it to the proper place if they don't want an exact value, okay? Now there is a way to put this directly into your calculator. Actually, there's a couple different ways, but I'll show you kind of the nicest one, I think, is to just just type in 42 plus, now we're going to take each of these fractions and just put them in the calculator. So you do 42 plus parenthesis 15/60 plus parenthesis 10/3600. And if you type that into your calculator, hit enter, you should get an answer of 42.252. And then, like I said before, your calculator is going to display a bunch of 7s and then an 8 at the end because it rounds up. But essentially, in reality, what you're looking at is a repeated 7. Okay. All right, so that's a quick conversion. Now we can also convert the other way, starting with the decimal and converting to the degree minute seconds. Okay, so let's take a quick example of that. Let's look at 15.6225 degrees, and we're going to convert that to degree minute seconds. To do that, I already know the 15 is my degree, the whole number degree on the end, so I'm going to just say that off to the side. okay? And what I really need to know then is going to be how many minutes and how many seconds are represented by this decimal, okay? So I really just need to work with a decimal. To figure that out, I want to know what portion of a degree is 0.6225, or how many minutes are represented by that decimal. So we're going to take the total number of minutes in a degree, which is 60, and multiply it by that decimal, okay? So to get the minutes, we take 60 minutes multiplied by 0.6225, okay? And again, I throw that in the calculator, 60 times 0.6225, and I get 37.35. Okay, so this would really be 37.35 minutes, but we really are only interested in the whole number of minutes because the 0.35 is actually going to represent the number of seconds. So I'm going to take the 37, that's going to be my number of minutes, and then again I want to see how many seconds are represented by this 0.35 minutes. To do that, I'm going to go with another 60, that's how many seconds are in a minute, and I'm going to multiply it by the 0.35. And when I do that, 60 times 0.35, we're going to get 21. Okay, so you guys can follow along with your calculators too and just check and make sure I do these right. Okay, so that's going to be 21 seconds. All right, so 15.6225 degrees is equivalent to 15 degrees, 37 minutes, and 21 seconds, okay? And of course, you could always check that on your calculator. If you were to type in, let's put this up here as a check, you could do the other conversion like we did a moment ago and just make sure it works out to this decimal. So you could type in 15 plus 37 over 60 plus 21 over 3600. And when you put that in your calculator, you should get out 15.6225. Okay? All right, that should work out nicely. Another thing that we're going to talk about with angles is so we looked at small divisions of angles, but we're also going to look at really large angles. Okay. If you can imagine going around a circle multiple times, the number of degrees that you go through is greater than 360. Okay, so imagine a tire rotating or a Ferris wheel, going around a Ferris wheel. The second time around or the third time around, you've gone more than 360 degrees. And so we're going to look at something called coterminal angles, where you get larger and larger degrees, or you may go negative and further negative degrees because you go backwards. Okay. Okay, so an example of coterminal angles might be starting with a 30-degree angle. Let's start with that. So we'll go with a circle and put in roughly a 30-degree angle, okay? So now, a coterminal angle just means an angle with the same terminal side, okay? We're going to assume all angles have an initial side going straight out to the right, okay? Some people think of that as like the positive x-axis if you had like an xy axis. And so the terminal side is going to be on the 30-degree angle, okay? Things that are coterminal would be if you were to add another entire revolution to that, so another 360 degrees, okay? So if you add 360 to the 30 that's already there, so you go one extra rotation around, 30 degrees plus 360 is 390 degrees. So 390 is coterminal with 300. I'm sorry, 390 is coterminal with 30 degrees. If you were to add another 360, go around the circle again, you would end at the same angle, but it would have a different measurement. So 390 plus another 360, that would add up to what, 750? Okay. So 750 degrees. Okay. And of course, you keep doing this. Keep adding 360. Every time you add 360, you get a coterminal angle, coterminal to 30 degrees. Okay. Now you can also go backward. You can you could subtract 360. Okay. And so instead of adding, you go around the other way and clockwise and subtract 360 degrees. And if you do that, you start with 30, subtract 360, and you would get negative 330 degrees. Okay, so that's also coterminal with 30 degrees. And if you were to again subtract another 360, so negative 330 minus 360, you would end up with a negative 690 degrees. Okay. And again, you can continue that process, subtracting 360 over and over and over again. Okay. So in the end, we would say that 30 degrees, 390, 750, negative 330, and negative 690, and many others, an infinite number of other ones, are coterminal.